Hello, it's Dr. Daystorms again, and now we're going to go over the actual mechanism that I want you to know. In particular, this is the chain reaction mechanism of free radical halogenation. Okay, so there are three, I hate saying steps, but there really are three phases in a chain reaction mechanism. The first step, or the first phase, is called the initiation. And so here, what we have is, let me change color to make it really obvious. Remember this, if you remember from the last video, this requires heat, like extreme heat and or light. Okay, and it is a homolytic cleavage, so we have one electron that goes to each bromine. This is free radical bromination, but bromine and chlorine are the ones that work best. And so then you're left with two bromine radicals. Okay, these radicals are not happy. They're going to go on to the next step, or the next phase. But you had to first have that initiation phase. The next phase is called propagation. And there's actually two possibilities. Now this is showing with methane, but you can actually react this with essentially any of the alkanes under the right conditions. And we already talked in the last video about how methane is more difficult to abstract the hydrogen than, ethane, or than a tertiary carbon radical formation is the easiest, if you want to think of it that way. Okay, and so in this second step, or the second phase here, there really are two possibilities. You can have that bromine radical right there, and it comes, and if you remember from the last video, it abstracts that hydrogen, but one of the electrons stays with the hydrogen, one goes with the carbon group, and so we have two radicals. We have a new radical. That's why it's called propagation, because it's going to go and propagate the chain reaction. And then we have the hydrogen halide, which in this instance here we're talking about hydrobromic acid. This free radical here, is not happy. And so in the second step, or the second portion of the propagation, we have the methyl radical now coming, and it can actually attack another halogen. Remember, halogens are diatomic, another bromine, and one electron goes with that bromine, and the second electron goes with the other bromine, and so now we have an alkyl halide. So here would be bromomethane, and we have another bromine radical. This bromine radical can then go and just repeat or propagate this reaction over and over and over again. Hence the reason why it's called the propagation step. That's going to continue. That's why it's called a chain reaction. It's going to continue until you get to the third phase of this mechanism. That third phase is called termination. Termination is quite simply the way that you run out of fuel for your reaction. The way you do that is two of the radicals react together to form a covalent bond between the two radicals. So how is that possible, or what are the possibilities of that? Then let's look. So the possibilities here that we're talking about, we could have a bromine radical and a bromine radical coming together to form Br2, the elemental bromine once again. You could also have the bromine radical in this instance. And if you use up, or you're starting to use up all of the alkyl groups around, that bromine can hook up with that radical, the methyl group, and we get our final, or our last bromomethane in this instance. Or, and the likelihood of this one is just really small, but in theory you could have two methyl groups, or two methyl radicals coming together as well, and in this instance you'd be forming ethane. However, the likelihood of that is quite small, so this would be a very, very minute product in this instance, to where our primary product really is the alkyl halide that we were wanting to form. So that's going to be our major product by far. And so, as I mentioned in the first video, this is a really handy tool, because oftentimes next semester when we're starting to do syntheses reactions and start to try to figure out how to make different compounds, and one of the first steps that we do is free radical halogenation. So hopefully this has helped explain the mechanism and the 3 phases of this mechanism for free radical halogenation. I will see you in class.